Good afternoon. My name is Jo Decker, Vice President, Business Winning and Strategy at BAE Systems and President of AFCEA DC. On behalf of the Board of Directors of AFCEA Washington, DC, I want to welcome you and thank you for joining us today for our virtual webinar on 5G. We have an excellent speaker lineup for you this afternoon. Before we begin today, in honor of Veterans Day, I would like to take a moment to thank all current and former members of the armed services. Our country's greatness is built on the foundation of their courage and sacrifice. I'd also like to express my thanks to the AFCEA DC Board of Directors. Through their support, we are able to get the high caliber of speakers that you will see today. To all the board members in the audience today, thank you. A few housekeeping events for today's event. If you have questions for the panel, please use the chat feature to ask the moderator. Sal Dietrich of the National Spectrum Consortium will be addressing the audience questions throughout the panel. If you have tech concerns, please use the chat feature and we will assist as quickly as we can. Immediately following our panel discussion, we will have virtual networking. The link to join the networking session will be provided in the chat box prior to conclusion. This month, to begin our program, I am also honored to present our STEM Teacher of the Quarter Award to Ms. Margaret Moore. Ms. Moore serves as a science teacher at the National Academy Foundation Information Technology Academy, is a valued team leader in the STEM department and consistently showcases a dedication and drive to support all scholars, as well as ensure her dedication to top-notch teaching and learning practices. To showcase her dedication to STEM instruction and college and career awareness, she has taught chemistry, AP Chemistry, NAF Intro to IT, NAF Intro to Networking, robotics, mobile app development, environmental science, environmental sustainability, and AP environmental science. Quite impressive. As scholars struggle with distance learning, Ms. Moore's students attend her class daily, are active participants, and enjoy learning. To support these goals, Ms. Moore designs lessons on various platforms to engage scholars and push their thinking and critical learning. The time she devotes to planning and student support is an example for all teachers. Champion of project-based learning and has spearheaded this critical format across the department. The students are invested in their learning and can apply their knowledge or practical scenarios. Along with teaching, she is also on the science curriculum writing team, district-wide STEM Fair Committee, and leads professional development for teachers to learn online tools for instruction. Notably, she recently served as a panelist at the Labster Science Online Conference, a division of TED Talk. Her topic was, how can high school teachers get back in a groove during the pandemic? On behalf of the chapter, I'm honored to present this quarter's STEM Teacher of the Quarter Award and a $1,000 check to Ms. Margaret Moore. Congratulations, Ms. Moore. Now, before I pass the mic to our MC for today's event, I want to tell you about AFCEA DC's Toys for Tots program. Although we will not be able to host the Winter Gala this year, we wanted to bring our AFCEA DC community together in the spirit of the holiday season. A staple at the gala, we reimagined our annual Toys for Tots drive as the 7 weeks of giving. Each week, we release a prompt and a poem and encourage you all to donate a toy in that category. Individuals can donate a toy, or your company can be a corporate partner of the Toys for Tots program. Please help us deliver a memorable holiday season to deserving local children and click on the link in the chat box. We currently have over 1,000 toys donated, and we need your help to get to our goal of 5,000. I'd now like to introduce the host of today's event, James Hansen, Vice President and Publisher of NextGov and the Vice President of Programs with AFCEA DC.
Thank you, Joe. And congrats again to, it sounds like I have some audio feedback. I'll push forward and make this as quick and painless as possible. I do have a few thank yous and announcements to make myself. And thank you again, and congrats to Ms. Moore for her service to our future leaders. We couldn't do this support without our great AFCEA community today. So as with all of our events, I'd like to thank our sponsors and partners for their contributions that allow us to host these and give back to the chapter's scholarship program and teachers like Ms. Moore for their work in STEM. So first, thank you to our program sponsor, Hitachi Vantara Federal, our lead sponsor, NetScout and Immix Group, our premier sponsors, AT&T, Citrix, Comcast Business, CommScope, CrowdStrike, Fortinet, Informatica, Leidos, Lumen, Micro Focus Government Solutions, NetApp, OpenText, Oracle, Red Hat, ServiceNow, Steel Cloud, T-Mobile, Veritas, Verizon, and Worldwide Technologies, our small business sponsor, OROC Technologies, our media partners, Signal Magazine, Defense One and NextGov, FedScoop, and last, our supporting sponsor. Again, thank you to all of you in our audience and support our chapter and the defense and national security communities. Secondly, I want to express my gratitude to our virtual event series committee for their time and dedication. Specifically today, I want to thank and recognize our 5G committee who really led today's programming efforts in putting this together, and whose companies, again, are helping move DoD and government advance 5G. Our committee leader, Mike Strunk from AT&T, Joe Beal and Chuck Mowry from Cisco, Randy Clark, Mark Kress, and Nick Nyland from Verizon, and Rick Pena from Worldwide Technology. Thank you guys again. Today's event focuses on 5G and installations, and we're thrilled to announce that in the springtime, we're also going to be hosting a dedicated virtual half-day summit focused on 5G. That's where we'll dig into some of the deeper challenges that DoD must overcome to truly harness the power of 5G for military operations, with sought-after speakers, including some of the ones I'm sure that we have today, which we're thrilled to have. Registration will be opening up soon, but mark your calendars now for April 7th. And if you have any questions about the event, how to get involved in the committee to shape the conversation, if your companies are interested in underwriting it, just reach out to our registrar at dcfceachapters.org, Tara Fish, and she'll help get you more involved. Last announcement before I turn it over to our moderator is our next virtual event of our monthly program series is going to be January 14th. We don't have anything planned for December, but we'll be building up for our annual DISA event. We're excited to have already confirmed Admiral Nancy Norton to provide some opening remarks, as well as a panel of the key DISA stakeholders and leaders that'll be led by Major General Garrett Yee. So that is one of our biggest programs of the year. Again, you can attend from anywhere in the U.S., so I highly recommend. The registration's already live on the AFCEA DC website, so please get involved. If you want to post and share some of your thoughts about today's content, use hashtag 5G, as well as our monthly events, hashtag Common Defense. So with that, let's get to the main event. I'd like to bring on Hitachi Vantara Federal to our virtual stage to introduce our great panel today.
Hey, James, thanks. Good afternoon. My name is Ryan Hinkle. I'm with Hitachi Vantara Federal. Hitachi Vantara Federal is an end-to-end data services provider focused on supporting our federal customers, DoD, and their mission. We are an active member of AFCEA, and I thank you for hosting this event today. And now I'd like to take a moment to introduce today's panel. Colonel Sean Branch, 5G Program Lead, U.S. Army. Frank Konechny, Chief Technology Officer, U.S. Air Force. Dr. Daniel Massey, Program Lead, Operate Through 5G to Next Gen Initiative, Department of Defense. Brigadier General Patrice Mollison, Tyndall Program Management Office, Executive Director, U.S. Air Force. Lieutenant Colonel Brandon Newell, Director, Southern California Tech Bridge, Naval X. And moderating today's panel is Sal Dietry, Chairman, National Spectrum Consortium. Thank you.
Great. Thank you, Ryan. And thanks, James, for that wonderful introduction. And thank you, AFCEA, for asking me to moderate today's panel. I'm Sal Dietry. I'm currently the elected chairman of the National Spectrum Consortium. My only observation to sort of kick this off is we're at a time now as we look at 5G, so critical to the enterprise. And really beyond what 4G, really 5G is focused on. One of its major focuses is on that enterprise market. And we're seeing a lot of traction both in the commercial industry, but also within the DoD. And I always like to think of DoD as the first enterprise. Certainly, if we look at some of the activity in 5G, we've seen in the past 12 months, that plays true. DoD's been a leader in deploying 5G and looking at some of things through work from the National Spectrum Consortium, but other consortium and other groups to really look at 5G and what it can offer to the DoD. Today's topic is critically important as we think about 5G, again, in the enterprise context around smart bases. I'll go ahead in today's format. I'm going to kick it off by asking each of our distinguished panelists to spend a few minutes talking about a question that I'll pose to them. And then, given our time frame, I'm going to open it up as questions come in through the Q&A. I've got some questions of my own, but I'm sure we'll fill the time. So, as the panelists go through, start thinking about those questions and start queuing them up. I'd like to start off with you, Brigadier General Melanson. Thank you so much for joining us. Your perspective at Tyndall Air Force Base is incredibly timely. As Tyndall is rebuilding and 5G is emerging, how do you see 5G enabling the mission at the new Tyndall Air Force Base?
Hey, thanks so much. I'm really pleased to be here. So we are definitely looking at how 5G is going to enable us to reimagine Tyndall as the base of the future. We, as some of you may know, we are getting a new mission. We'll be receiving the first F-35 aircraft in September of 2023. That aircraft has the ALICE system, the Autonomic Logistics Information System, where the plane is talking back to the folks on the ground while it's flying with data on the systems of the plane, so that when that plane lands, if there are issues that need to be addressed, those technicians on the ground are going to have gotten word ahead of time about that. And so they'll be prepped to really do a quick maintenance or check and be able to turn that aircraft really right away. So that's one of the aspects. The other aspect that we're looking at is taking data from sensors that already come pre-installed on infrastructure systems like power systems or HVAC systems. Those sensors are coming pre-installed. I mean, that's typical nowadays. But right now we don't really do anything with any of that data. So we are looking to develop at Tyndall the Installation Resiliency Operations Center that's going to serve as that repository to collect that data and allow us to do kind of two primary things. The first is to allow us to really start moving towards condition-based maintenance of our built infrastructure and predictive maintenance of that built infrastructure. Right now, that maintenance is done pretty much based on the manufacturer's recommendations, or the system completely fails and we have to replace it. So we're looking to really do maintenance at the sweet spot. That's going to allow us to really be much more effective with our sustainment dollars. That, as we all know, we live in a budget-constrained environment. So we'll be much more effective with that sustainment money, and also be able to, as we really do that maintenance at the right time, we'll be able to extend the overall life of our built infrastructure. The other aspect is for our first responders. we are looking at adding a number of sensors that will be related to base defense at Tyndall with the rebuild. Some of those things are occupancy sensors. We already have intrusion detection sensors. We're adding gunshot detection. And so having a place for all of that data to come together and be synthesized and produce, take that data and turn it into actionable information, that's going to give our first responders a much better real-time picture of what's happening. If there is a gunshot, they know exactly where that happens and then can look very quickly at the buildings around that area and figure out, are they occupied? If they are, about how many people, where are those people in those facilities? So it gives a much better real-time picture for our first responders. So those are kind of the two big areas that we're looking at. And obviously, all of that sensor data takes up a lot of bandwidth. And so having the ability to utilize 5G to let that data go back and forth. Edge computing is also something that is becoming more commonplace. So we're looking to be able to use that edge computing to allow us, again, to do those kind of algorithms and use that machine learning and get much quicker actionable information out of that data.
Yeah, thank you for that. And thank you for sharing that life-saving use case and mission with us that 5G will undertake. I'll come back to you and talk a little bit more about Tyndall as we go through the effort. I'd like to ask you, Colonel Branch, kind of building on what General Melanson said, as cloud and 5G are converging, and again, this theme of DoD as the first enterprise, what do you see as 5G opportunities for the Army, whether it's here at a smart base or perhaps a forward operating base? Offer us some of your thoughts, sir.
Yes, good afternoon. And first of all, thanks for inviting me to participate on this panel and to talk a little bit about what the Army is looking at in terms of adopting 5G technology. So many may be aware of the DoD effort, and so the Tranche 1 and Tranche 2 efforts, Tranche 2 being recently announced. And so for Tranche 1, what the Army is really focused on there, out at Joint Base Lewis McChord, we're focused on how does 5G enable augmented and virtual reality to really provide us realistic combat training with the purpose of increasing readiness and lethality for our soldiers in what we're calling, you may have heard the term, synthetic training environment. That's all about providing the most training that's as realistic as possible. And so that's what the focus is on our first tranche. The second efforts at NTC, at Fort Hood and Joint Base San Antonio, those are all part of the second tranche efforts. Specifically at NTC and Fort Hood, we're really looking at command post mobility, command post survivability, and then also how does 5G enable vehicle and platform mobility. And then for the Joint Base San Antonio location, that's a joint effort with the Air Force. And so, what we're looking at there is the Air Force looks at DoD 5G core network. The Army's interest is really focused on, how does 5G enable us from a telemedicine perspective. So that's the focus at Joint Base San Antonio. And so, the Tranche 1 and Tranche 2 locations are part of the overall DoD effort to take a look at 5G and the use cases. And so those are primarily focused on tactical training and tactical capability. But at the same time, the Army is also looking at it from an installation perspective. And so we're starting to turn our focus a little bit more on advancing technology for smart installations. And so, some of the things that we're looking at the range of technologies, right, that get us from where we are today to what we see as a smart installation. And so some of those technologies include some of what the Air Force is doing, what was previously mentioned. Some include sensor-based capabilities, next generation Wi-Fi, active passive protection systems, all with the purpose of supporting readiness and also providing real-time awareness and also improving working and living conditions on those installations. And so some may have heard about the Army's Installation of the Future initiative that's been talked about. So it's really under that concept and that vision that we're really starting to turn our focus and efforts towards how does 5G technology enable an installation of the future. And so again, thanks for that question, and thanks for having me here to talk a little bit about what the Army is doing.
Yeah, thank you. Thanks for incorporating the mobility aspect of it and a number of the bases and use cases that the Army's pursuing. Since you mentioned the Air Force, I'll come back to Mr. Konechki. Sir, tell us a little bit about, I guess, an overall vision for the Air Force and 5G and its mission. As CTO, you're looking across a number of things. You've been heavily involved in Tranche 1 and Tranche 2, but perhaps share even a broader picture with us about where you see 5G fitting into the Air Force mission.
I mean, we've always talked about having, the smart base, the smart depot, and everything else associated with it. And I think between the mobility pieces and everything else associated with it, that's, we can go into depth about that. I mean, sometimes, like for Hill Air Force Base, we're looking at how the AWACS radar can work within the spectrum that is being sold off, and difficulty as to, how it's going to interfere with everything else, as well as other aircraft radar systems as well. So we're looking at that from a viewpoint of how can we share the spectrum with the commercial entities. And this is something that Tinker Air Force Base is also working with. I mean, we're working with, of course, augmented reality in various ways. Sean mentioned it. We're doing that. He's doing it for various places at the bases. We're also doing it in Honolulu for aircraft maintenance and activities. We're also probably doing some at Tinker now, as well as for education purposes. So I think we're all looking at how AR, VR can actually support our missions out there. What's interesting is also at Nellis is kind of interesting because this is going to be the way we think we're going to work and fight. Basically for Nellis, we're taking the Air Operations Center and segmenting it into different components that could be mobile and they can link to each other while they're moving, with the idea that a target that moves is difficult to hit as opposed to a stationary target. So as we talk about joint fighting out there with, in a mesh, a 5G mesh network that may have aerial components as well as land components, as well as satellite components, this is probably the first experiment that's going to probably track all three of those at some point in time as to how we will actually manage an air operations center as it moves in different locations across the United States or in the same and within the same range areas as we look at it. So I think we're trying to figure out how to basically do this in terms of communication. We're talking about network slicing in this. We're talking about having different sensors that the user could actually interface with, gestures, sound, tactile, standard tactile gloves that always the VRAR wants to have, are probably going to be there too. So it's going to be a question of how this will actually work in a true environment that we actually have to maintain. Further on top of that, we talk about sensors. Yes, we talked about, we're doing various small business initiatives right now with sensors because we found that we had lots of equipment that didn't have sensors on it. So for instance, we have gone farther with a small business initiative to actually have sensors on steam traps and other machinery that are powered by the steam or the heat as well as the motion of the motors. So we're grabbing these sensor data off that we didn't have before, and we're looking at how we can conglomerate them into a 5G network and look at it from, how can we manage the sensors? And we want to do network slicing to manage those sensors from the equipment as well as the sensors from the F-35, as well as the sensors from the assembly lines that we have at the depots, and looking at how we can actually combine these together on a base network. So it'd be probably a separate 5G network, as well as looking at how the open RAN concept that we are generating at the base can actually be utilized, like at Hill or at Tinker or at any of those locations, and actually provide us with that private network. And on top of that, of course, we have the mobility issues of how you're going to move around, because the mobility issue is a big deal for the flight line, for everybody else on the base, how you want to manage this, because as we go forward, as we developed an LTE at the bases, the big issue is I want to be able to be movable, everything I do at the flight line and every place else. And so when we talk about, 5G is going to give us the bandwidth, I think, to do it. However, we have to figure out how we're going to consolidate everything, probably at micro or mini data centers at the bases, to do the analysis and figure out how we're going to do that. Because you can't send all the information that we're getting off of the F-35 or any of the other planes across the network to someplace else. Some that's going to have to be done at the base level so we can do the consolidation and maybe do the preventative maintenance activities, even though you will have to send the data at some point to do the training. That's different than actually operations data that you have to have at the base level. So a wide range of activities, all associated with mission orientation, but it also has a commercial side to it as well. So you got to think of it that way. How can you utilize these on the commercial side? And a lot of the sensor data that we're getting, as well as we're doing like a quantum key distribution that we're trying to put eventually onto a 5G system, how is that going to apply, for future security issues that we probably will have? So overall, we're looking at 5G as a mission capability that we want to have across the board.
Yeah, thank you for that wonderful enterprise view of 5G. You touched about the interoperability and so many systems that need to work together. You also touched on spectrum access, which is a critical piece of this, whether we're talking about CONUS or OCONUS, and how that plays into the 5G rollout. You also talked about agility and small businesses' role and sort of innovation, and that's an area where, as we're rolling out 5G, there's tremendous, I think, opportunity for U.S. innovation and this creative collaboration between Silicon Valley and traditional players in the commercial side, traditional players on the DoD side. I'd like to turn to Lieutenant Colonel Newell, who's director of the SoCal Tech Bridge for the Naval X, and tell us a bit about how 5G fits into what you're doing out in the sort of agile cutting edge of this, and where you see some capabilities coming in 5G.
Thanks, Al. Yeah, it's a pleasure to be with everyone today from San Diego. One of the benefits of a virtual event is that I can join you like this, so it's great. We're doing a lot on Marine Corps Air Station Miramar here in San Diego, where in July we turned on the 5G Living Lab in our partnership with Verizon. That goes back to 2018 when we first started ideating around what we would do. And we went through a couple years of iterative design and then creation in how we roll it out and what we're exploring. Our effort sits outside of the OUSD R&D program, Tranche 1 and Tranche 2, and that gives us a lot of agility in how we move forward and how we help close knowledge gaps and concept of employment gaps for all of DoD. We're the advocate of everything and the stakeholder of nothing here. So, we welcome, everyone leveraging our efforts. So I wanted to spend a minute and talk about the specifics of what we're doing in this program. So with the 5G Living Lab, we wanted to focus on not the network itself, but the enabled technology that the network is enabling. And so we picked 4 pillars of exploration. First, energy communications and how you can use 5G and cellular for intra-transport of data and connectivity on the base. Second, connected vehicles, so the advancement from autonomous vehicles to connected. Drones, we believe the future of drones goes from RF to cellular control. And then the final one is what we call the digital fortress, which is complements our physical fortresses we built today. We have 7 pilots that we've kicked off for this fiscal year alone. The first of which was under that digital fortress and is live today, where we have a company called Anduril, a sensor suite that has computing on the edge and artificial intelligence helping us increase our security posture across the base. We installed towers just a few weeks ago. Those are tied back to the cloud through cellular, and we're learning a lot from that effort. Second, I want to point out the pitch day we had a 5G pitch day just 2 weeks ago, where we awarded 4 different companies $50,000 check award. And now those 4 companies are working with Verizon and our project manager, US Ignite, that's over the 5G Living Lab, to design the demonstration that we're doing with those 4 companies in February. Our whole model is to create these collaborative markets and collaborative opportunities that our research and development arm cannot lead efforts, but analyze efforts led by industry. And we're co-designers and co-creators along with industry, and in specifically Verizon here for the 5G Living Lab, who's a great partner. In December, we're kicking off our autonomous shuttle movement of parts. So we're supporting the Marine Air Logistics squadrons on the base by moving parts with a autonomous shuttle. Locomotors Ollie is the shuttle. We have 2 of them on the base right now. We're prepping the route as we speak. Now, these are not connected vehicles. These are autonomous vehicles. You know, the eyes and the brains are all on board. But what we found in our effort with the Army at Joint Base Meyer, Henderson Hall, in Arlington, was that the data export each night of the terabytes of data back into the cloud is a huge problem on bases that, you know, cellular is basically off limits historically for us in DoD. We want to show how 5G allows us to export that data quickly and safely out to the cloud. We have other efforts, a follow-on effort from the installation type parts delivery is a program that's funded by the Office of Secretary of Defense for Operational Energy, all about unmanned logistics systems. We built a prototype of ground and air assets that move resupplies this past year. We demonstrated that first prototype in July. It was connected on a closed network, 4G LTE network, connecting those 3 devices. We're iterating on that design, upgrading the ground autonomous vehicle, making it more commercial and capable. And then we're going to bring that back onto the base in May and integrate it into the 5G Living Lab. And so what you're seeing here is not a network from looking within the network, but it's looking at a network from outside, where the enabled technologies are guiding us in our understanding of knowing how we write those requirements and how do we create the pipeline in the program of records that are going to be touched by 5G.
Thank you for that. What I heard and what I really enjoyed hearing was that all of your use cases have dual use application. There are commercial industries in logistics and other areas that would benefit from a lot of what you're doing, and the companies that you're working with who are so innovative in that area. You also touched on jobs, which I think is really important. One of the things we've done at the consortium is had a labor economist develop a full report on what kind of jobs is 5G going to create. With all this money being poured in innovation, there's clearly an educational gap there in the learning curve, the power curve of things like mobile edge computing, 5G, we're talking about new networking. So we've got to get our workforce up to speed. And we've got to get people smart so that we can continue to be the leader in this from a national perspective. So thank you for that. With that, when we talk about sort of on the national stage and the program itself, I'd like to turn to Dr. Dan Massey, who is the program lead for the Operate Through portion of Dr. Joe Evans's 5G to Next G initiative. Please share a little bit about the program and where you see this going, particularly with relation to smart bases.
Sure, thanks, Sal. So I'm very happy to be here. So we've got a pretty exciting program in OUSD R&E, and I know a lot of folks are already familiar with that, and we've already referred a little bit to Tranche 1 and Tranche 2. So let me set the stage with sort of the big overall picture. Right, so the 5G initiative, 5G to Next G initiative, is really split into 3 key parts. The first part is Accelerate, and we've already talked about that a little bit. Accelerate's rolling out Tranche 1 and Tranche 2. Accelerate is really meant to, as the name implies, accelerate the use of 5G in DoD scenarios. We've got a lot of interesting scenarios. Some of the use cases were already described far better than I could do by the other panelists here. Let me point out some of the technology aspects I think are pretty cool about that, right? So at Joint Base Lewis McChord, as was already mentioned, right, we're looking at AR, VR, and to do that well, you're going to need both high bandwidth and low latency, right? And that's something that 5G offers, is that real high bandwidth, low latency. We've got some interesting smart logistics that have also been mentioned a little bit as well. Naval Base San Diego, Marine Corps Logistics Base Albany. There, again, one of the aspects of 5G is the scale, right? So, you know, we can scale to the point of having everything in the warehouse on the network, to having all the components. So, you know, with the AR, VR experiments, we can look at the bandwidth and the latency. With the logistics experiments, we can demonstrate some of the scale. Out at Hill Air Force Base, as was already mentioned, there's a lot of interesting stuff going on the spectrum sharing, the spectrum agility. So there's a lot of cool features that are coming with 5G that we need to exploit. So that's our overall Accelerate program. When people talk about the Tranche 1 and Tranche 2, they're referring to Tranche 1 and Tranche 2 of the Accelerate program. And you know, I won't bore you with, I could take the rest of this panel describing all the cool things going on and all the bases, but I'll leave that for the Q&A. So let me give you the other 2 legs of the stool on the program, though. So we've got Accelerate. putting this into the bases, tranche 1, tranche 2, cool stuff, Now, my piece then takes that and says, okay, let's look at operate through. And it's already kind of alluded to here in the panel. There's a lot of commercial deployment of 5G, right? That's happening not only in the U.S. but globally. How are we working with that commercial environment? How can we work with that commercial environment? How does that impact DoD operations? And that's what we're trying to look at with operate through. So I've got a bad analogy that I'll share with you guys, but if we look at, say, other infrastructures, whether it be host country power, host country water, the road infrastructure, right? DoD, of course, if we focus on the road infrastructure, DoD, of course, is always going to have the ability to build a bridge to span a river, right? We need that capability. We need to do that, but we also make use of existing bridges, existing roadways when they suit our needs. Right? We do that for host country power. We do that for water and so forth. What about commercial 5G? Can we make use of commercial 5G in other scenarios, in CONUS, in allied countries, in gray or contested areas? And I think that's an interesting question, and that's part of what we're going to explore. And it's part of what Operate Through is charged with exploring, is how do we intersect with the growing commercial 5G? Can we leverage it? And of course, can we do that securely? Right? A lot of interesting stuff for the cybersecurity folks, and I'm one of those cybersecurity guys. This is true zero trust cybersecurity. I have limited, in fact, zero trust on the infrastructure in an allied or even contested area in terms of 5G. But maybe I can still make use of it. So we've got last thing, and then I'll go back to the panel questions. Right. So accelerate, looking at what we can do at the bases, tranche 1 and tranche 2. A lot of expertise, a lot of interesting things happen there. Operate through, looking at, okay, we're existing in this commercial 5G world. What can we do to leverage the commercial 5G? What can we do in a zero trust basis to understand how that's working? And of course, the third piece of the stool is, the third leg of the stool is the innovate part, right? Because while we're all focused on 5G and we've got a lot of possibilities in 5G, we also know 5G is not an endpoint, there's a continuation. So what goes beyond 5G? So at more of a research level, that third leg of the stool is looking for what might be occurring after 5G. So that's the big program. I can speak to any of those parts. I'm particularly interested in the operate through part, as that's the piece I'm leading. But with that, I think I'll pass it back to Sal, and that's kind of the overview of what OUSD RNE is doing.
Great, thank you. So we're generating questions. They're coming in a little bit, a little slowly here. I'll go back and perhaps ask you, General Melanson, what are some of the tools and things you see rolling out, but also is the 2 or 3 key things that you're hoping to get out of 5G, or the 2 or 3 sort of risks that you see at this point with 5G? Could you elaborate a little bit more on what you're doing at Tyndall and what you might see as the top 2 or 3 tools or applications, capabilities, but also what might be the top 2 or 3 risks that you see or concerns with 5G?
Sure. So I think certainly the primary risk is one that I think everybody will agree on, and that is just the whole cybersecurity aspect. We need to be able to process all this data in an effective way, but we also need to be sure that we're processing it in a cyber secure fashion, particularly for things like our industrial control systems and our facility related control systems. Those, we definitely need to have that layer of cybersecurity on them. So that's probably, I guess, the sort of the biggest risk that I see with that. As you know, the military is a relatively risk averse group. We're getting better at that. Certainly with General Brown's edict to accelerate, change, or lose. We're getting better, but there still is a lot of kind of risk aversion But you know, so that cybersecurity piece is going to be key. And really, again, looking at having the ability, for instance, on our cybersecurity side, in addition to the Installation Resiliency Operations Center that I mentioned, we also have awarded an OTA through AFWorks to develop a digital twin of the base. One of the aspects that's critical for is we are also looking at additional perimeter defense sensors. In fact, we've got, there was a demonstration just on Tuesday to the IMSC commander of what effectively are what we're calling robot dogs. The official name is a quadruped something, but they're effectively robot dogs. So those, you know, Tyndall's got 29,000 acres and 129 miles of coastline. And clearly we can't have people, you know, out there all the time. So these unmanned robot dogs are going to be able to, you know, detect and sense data and then send that back. And they will be linked up with that digital twin of the whole base so that we know really, you know, where that data is applicable. So that's kind of one aspect. And then again, as I mentioned, the ability to be more cost effective with our infrastructure, and then also the infrastructure sustainment, but also just the operation and maintenance. If we can figure out a way to use the data that we're collecting from some of these facility sensors to allow us to maybe be more energy efficient and effective, you know, again, that's going to be cost savings in the long run for the Air Force.
Thank you very much for that. Thank you. We've got some questions here now in the chat that are forming. Let's go. Said Dr. Massey, it says you. This one's for you. You mentioned a zero trust operate through. Are there holes with 5G ZTA that vendors need to be concerned about, or I guess within the tranches as you're looking out at it, are there certain capabilities that you're thinking for the operate through where ZTA needs to be beefed up or you know, augmented in some way?
Yeah, thanks. That's a great question. So yeah, and I think you know, General Malakon had already kind of touched on some of the critical aspects there, right? So as we put more and more data over this, right? Obviously, we need to ensure the confidentiality, integrity of the data. We also need to ensure the availability, and what we want to push is this idea of, let me take it to a more extreme scenario. I'm not running on a Tranche 1 site, but I'm running in some kind of integration synthesis with a commercial 5G provider, which may have supply chain components that frankly I would never put in a DoD installation. So what we're looking at especially is, what's the level of vulnerability that we have on the underlying infrastructure, right? And can we provide some guidance both to the deployment at the bases, the Tranche 1 and Tranche 2 deployments, to say, hey, be watching for this, right? Look out for this manipulation of control messages, this attempt at a denial of service, you know, this exfiltration of data. But even more so, can we provide guidance to allied commercial providers to say, hey, you know, we're recommending that you configure in this direction. We're recommending that you turn on these aspects of the specification. And I know all this is a little bit vague. We are literally launching now, so my overall recommendations for what we're going to do are still, you know, at the very initial stages. But I think that's the interesting question. How much security can we layer on top of a site deployed at any of the bases discussed here? How does that change as we move to sort of say, well, let's run on a what if we were including a network slice on top of a commercial provider in the US, a commercial provider in a NATO country, commercial provider in a different area? And what we're trying to do is remove that reliance on the security of the underlying, put zero trust in the underlying infrastructure. I'm not sure I gave a very direct answer to that question, but that's sort of the the challenges we're looking at. If that,
well,
if that
you
makes
bring
sense.
up an excellent point. Something the National Spectrum Consortium is involved in is there's more than just DoD going on at these 4 bases. We've got national centers of excellence, national innovation centers in 5G stood up now in multiple states and multiple universities. And shame on us as a nation if we don't grab that and start leveraging and running more experiments. Let's get multipliers going in many directions here. So thank you for that. Since we have a little bit of time, probably the hottest question in the group now is as a guy who's been around DARPA a lot of time, what's up with the vintage Mac behind you there in the picture? Everybody's asking about, what's going on with the vintage Mac there in the background?
That's my. We're putting 5G onto this, and that's my new. That happens to be an actual functioning Apple II.
Okay.
That's but I do think I'll twist that into an interesting kind of question or comment for the panel, which is what we're really seeing is that dramatic change in the infrastructure, right? That used to be a really cool. That was an advanced computer, back when I was young, right? And but nowadays, I've got that's got a fraction of what I got in my phone, right? As all of us do, right? So we think that 5G is offering an important pivot point here. We think that 5G is like one of those advances from the supercomputer to the to the small personal computer, from the small personal computer to the to the IoT device, the cellular device. So I don't think of 5G as just a progression from 3G to 4G to 5G. I think we've made some important structural changes. This idea that you can have a network slice, that you can really have this fully virtualized network slice. So I could layer I forgot who mentioned it, but somebody mentioned, I can have a slice for my sensors. I can have a slice for my facility repairs. I can have a slice for other communications. And I can achieve virtual separation, right, on those slices. They all might be running over the same hardware. Now, one interesting question is when we make that virtual slice, in theory, they are distinct pieces as much as we had rolled out entirely distinct hardware. In practice, can I get from one slice to the other? So the premise of putting the sensors on this slice, the aircraft information on this slice, the other slice was that they were distinct. And one thing we're exploring is, if I don't trust the underlying hardware, I have zero trust in the underlying hardware, can I move from one slice to the other? Are they really distinct? And I think we have this exciting kind of pivot in the in the communications infrastructure that that for me is going to be similar to the pivot from the supercomputer to the personal computer, from the personal computer to the independent device. And the way 5G is structured, I think, is a really fundamentally different change from 4G. And so I think there's a lot of exciting potential, but we got to manage that risk if we're going to do it right. That's
Yeah, when folks say it's bringing cloud to the telco world, the wireless world, they're not kidding with all that flexibility and opportunity. To build on that a little bit, I'll go back to Mr. Konechny. Talk a little bit about this interoperability. We've got LTE, we've got 4G and 5G cores. We've got operations CONUS and OCONUS. Opportunities to collaborate with host nation partners, NATO allies, opportunities to leverage kind of what I talked about, this national innovation explosion that's happening in 5G. How do you see some of the interoperability going both here in the United States and also overseas?
Okay, this is a problem right now. You probably realize this, that we have, and we're going to have a problem for a while, because as we develop 5G out here, the assumption, even if the network slices, that I'm going to go through a 5G network all the way, especially to Europe. And the answer is no, you're not. So the question always is, how is the security envelope going to contain itself as you go through for the network slices when I go from a 5G to a 4G to potentially a 3G someplace in some foreign country back to a 5G on a base? And that hasn't been resolved yet. That's going to be one of the security issues we have for interoperability. How can you maintain a slice through hardware that is old as well as new? And so I think that's one of the issues we're going to have to tackle at some point in time. Likewise, for the standards group that, OSD is actually participating in, and we are too, is that the security features that are in release 16 and release 17, a lot of them are optional. And so we talk about, we want to be able to test out the capabilities. We're going to have some way of certifying that the security features that we want are really there, as opposed to any place else. And as we go forward, that's going to be one of the questions. Now, we're going through, right now, we're communicating through equipment that is old, and we encrypt everything, okay? Because that's the way we want to do. However, the issue we're going to have is that, okay, we're going to encrypt everything, but, if we're going to hardware, you can delay it, they can stop it, they can redirect it. So that's always been the threat issue, as well as cut it off. And then we have to have alternative means of interoperability, be it satellite or some other method that we want to connect to. So when we talk about interoperability, we're going to have to go through various means to actually do that interoperability, be it SAT, be it other landlines, be it different ways of looking at it. And so I think that's where we're going to have to go when we talk about, when you go to foreign side and CONUS, we're still going to have these alternative capabilities available to us as we go forward.
Thank you for that. And I'll throw this open to the whole group. This is a question. I'm getting questions in the chat and in the Q&A, so I'm sort of ducking from all the questions now. If we look several years out and these early efforts are successful, we're innovative, what might a program of record look like in the years out in 5G? Would any of you like to maybe spend a minute or two just commenting on that?
I can. It's supposed to be mission oriented. We have flight line of the future. We're going to have that as basically how you do, maintenance activities at the flight line. And so I think have to base it on particular mission activities that we want to have, as opposed to anything else. Like we have the AOC that's going to be modernized too. So it's AOC modernization to use the 5G capability. So it's a capability that we're going to have to utilize as we go forward for mission, but it's not a separate entity, I believe, until itself. Just like AI is not a separate entity, it's a supporting entity.
Sal, let me build on that. My vision is that the power of cellular technology, whether it be 4G or 5G, is every portfolio manager is screaming for that power. And I liken it to, an electrician being the spokesperson of the power of energy versus every portfolio manager knowing how they need energy and how it allows them to grow their capability. Cellular has been closed off to us largely, right? We missed the 4G revolution. The 5G revolution is allowing us to even catch up with the 4G, the power of cellular in our personal lives and in everyone else's professional life. And so what I see is that you're going to see key performance parameters, key system attributes about cellular enabled tech inside every ground vehicle, inside every drone or air asset, inside every single portfolio that we will see coming and modifying in the future.
Thank you for that, Colonel Newell. Let me stay with you for a second, because one of the questions is sort of a statement. It says, will 5G and AI and quantum computing and some of these other things, are they sort of the third offset, right? Where this massive investment in quantum computing and quantum security is perhaps as important right now as 5G. How do you bring these things together? And we're talking about release versions of 5G. We're talking about early deployments at some of these tranche 1, tranche 2 sites. We've got a rebuild at Tyndall, but yet quantum computing is now coming on the scene. How do you see this working out through what you all are doing, or just sort of along the R&D pipeline, which has traditionally had issues in transitioning and putting these types of technologies together?
Well, I'll link it to my last comment. Every portfolio manager has no idea of the power of cellular to their future capability. They have no idea the power of quantum into their future. They have no idea about AI, right? The way we've engaged with industry to date will not suffice for this integrated, highly advanced capabilities that are enabling. And so we believe that you have to create these collaborative markets around these opportunities where industry and DoD are working together, and let the specific lead to the general. We shouldn't be writing requirements from a poor position of knowledge. We allow these prototyping and piloting efforts to improve our position of knowledge. we bring out those portfolio managers to see what the future of unmanned logistics looks like, or counter and looks like. And then for us, we do design think sessions with them and industry that help craft what does that future look like. And we fold that in to our iterative design process. And so I believe we have to be very iterative. We can no longer look at sitting across the other end of a contract with industry. We have to find more collaborative market opportunities, like the OTAs, like the collaborative research and development agreements that we use.
Colonel Branch, as we think about 5G and forward deployed operations, the warfighter, so much capability and opportunity there, but so transformational, but a big transformation. Share your thoughts on how you see the warfighter absorbing 5G, both here in the U.S., but also as he's deployed overseas, perhaps even in austere environments, perhaps the need for a tactical overlay or some other supporting infrastructure. How do you see this playing out over the next couple of years?
Well, certainly, as we look at 5G from a tactical perspective, that would appear to be much more of a challenge to determine how we can actually leverage 5G. So, one of the things that we've been doing, akin to the comments that were made earlier, as far as 5G being a program of record, I would hesitate to say that, because it's actually, it touches on all the different programs. As you look across the Army modernization priorities, it touches on each of those programs. So one of the things we've been doing is looking at what are the roadmaps in each of the programs to get to 5G. And so understanding that up front, going through these experiments to actually prove out how does 5G help us on the battlefield, or maybe not. And, obviously one of the challenges would be spectrum. We talk about spectrum, we talk about interoperability. While a capability may work here in CONUS for training, how does that work when you're talking our partners in other areas of the world when there's, different spectrum challenges? So those are certainly areas that we want to investigate as a part of these experiments. It's related to all the discussions on standards. What are those standards that allow us to operate with our partners? But certainly those are challenges that we want to try to prove out through these experiments.
Yeah, thank you for that. And spectrum being a key piece of that. You bring up the point as we're looking at 5G. Some have made the statement, the Army or the military that finds ubiquitous connectivity wins the fight, and 5G is just one piece of that. How do you see that rolling into the portfolio across the Air Force and the Army? We could be talking about things like Wi-Fi 6, 5G, tactical overlay, to get to sensors, to get to ubiquitous connectivity. Where do you think we are in that pathway? And I'd ask any of you to chime in on that.
Well, I'll start by saying, so you mentioned, Wi-Fi 6 as an example. I think it depends on, the use case and what the mission would be, because certainly, Wi-Fi 6 in certain, for certain requirements, Wi-Fi 6 is, is probably better, right? You're in a stationary, fixed type of environment. But then if you're talking for mobility, then, maybe 5G or 6G or whatever the next G is, would be a better use. But I think the key is being able to tie those together, and then also being able to look at the, from a data perspective, because as you tie all these things together and you get the ubiquitous coverage that we want to get to, you have to take a look at the data, right? Using analytics, right? How do we do analytics? How do we incorporate AI and machine learning, and then the security piece of it? So those are three pieces that we have to make sure that we look at as we looked at infrastructure initially, and now we're looking at applications and services. Well, you got to take a look at the data, and how do you bring that all together? How do you protect it? How do you leverage analytics and automated artificial intelligence and machine learning? Those are some key points that we have to make sure we don't miss as we race towards 5G and the next G.
We've got about 5 minutes. I could probably stretch it to 6 with this great panel. I'd like each of you maybe just to offer a 1-minute closing remark. General Melanson, we'll start with you, ma'am.
Sure. Thanks again for allowing me to come and talk about what we're doing at Tyndall. Really enjoyed hearing the other panelists. I've been taking some notes of things that we may want to look into, but certainly, we're going to need to have that connectivity and the ability to transmit lots and lots of data. So, so really excited about the way forward. Thanks.
Mr. Konechny?
I mean, we're trying right now to put LTE and 5G at all the bases. So we've succeeded in 10. We have a RFI out for RFQ, I guess, for 20 more. And so we are trying to be the ubiquitous, put it out there as fast as we can. And it's difficult because there's a lot of bases. But, we're trying to do that. So, we're trying to, that's the first step, to get the infrastructure down so that we can actually start doing the programs of record that meet the requirements. I mean, the OSD experiments are experiments. That moving them from the experimental stage to the production stage is going to be necessary. We may have to be using commercial 5G as well as an augmentation to simple capabilities that we actually have at the base level. So keep on trying, keep on moving out, and keeping moving towards the ubiquitous connectivity that we all want.
Colonel Branch, closing remark.
So yes, we quickly race towards 5G for the Army. It's all about how does it help us with readiness, JANC2 modernization and the 6 Army modernization priorities. So hopefully we can prove that out through these experiments.
Colonel Newell.
I'll leave you with, I recommend knowing that this is a DC crowd. You're right there with the seat of power, right? So I recommend centralized intent and decentralized execution. Whether you're a program, whether you're a service, we think partnerships are a local thing and they generate from relationships at the local level, but it must be guided by the intent of your hire. And so I'd encourage you to find ways to do that within your organization and your service.
Dr. Massey, you folks are driving the programmatics on the tranches. A closing remark, sir?
Yeah, first, thank you so much for having this panel. This is a great discussion. We're pushing forward on all 3 of these, the fronts of the overall program, the accelerate with the tranches, getting that in there. And as was kind of iterated here, that really needs to be driven by mission requirements. I think the way we fail is if we come and say, we have this cool technology, we have this cool hammer, what do you want to do with the hammer? That's not the right approach. It's more of, we have a mission need, how can we use the technology? So we're hoping to do that with Tranche 1. 2 last quick comments is for the folks that are saying, I'm more interested in how do we integrate with the commercial network? What is the intersection between the commercial network and the basis, proprietary system? That's the operate through piece. We'd love to talk with folks more about that. And then the third piece, which of Dr. Evans' overall 5G to Next G program, is that innovate for what happens next? What happens with quantum and AI and machine learning and all this sort of stuff? So I think we need to hit all those pieces, but the key thing from the best way to approach us is with a mission rather than a technology. 5G, we have no shortage of new technologies. What we want to see is how does that help actually achieve a mission? So thank you so much for having me.
Yeah, thank you all. Thank you all for the great discussion. With that, I'm going to hand it over to Vikram and the folks at NetScout to start the networking portion of the event. And thanks again, AFCEA, for having me.
Thank you, Sal. I think that was a wonderful panel. Just listening from the sidelines, the discussion around all the use cases, mission critical applications that the DoD and military wants to bring on 5G. I think the expectations are very high. I think to deliver on these expectations, the 5G technology has to be fully geared up. To be such a game changer, the steps that 5G has taken to pivot from a consumer-centric network to an enterprise-centric network and adopting all the new things, the higher sets of frequencies to deliver high bandwidth and low latency, the adoption of cloud-native technologies, Kubernetes, containers, the ability to bring in a lot more agility into the network so you can make the network more flexible and agile. all of these new things that are coming into 5G present a whole new challenge in terms of how do you secure and assure the network and the applications that run on it, such as the ones that folks talked about in this panel. This is where NetScout can really help. As a company, we have taken pride in providing the deepest visibility in all the commercial wireless networks. And what's happening with 5G is that you need to provide this visibility across this diverse set of components, the radio access network, the cloud native world, and be able to do it in a very agile and predictive manner. So you guys talked about smart bases. Our technology is smart data and smart analytics. We mine the network traffic and give you the deepest visibility through our AI-powered analytics applications. The key to success in 5G is going to be not reacting to problems, but be more predictive and more proactive. You want to catch these problems before they affect the application and disrupt your network. And I think that's going to be the key to the success of 5G in delivering mission-critical applications. And this is where I think NetScout technology and its power of smart data can truly help. So with that, I would like to just conclude and thank all the attendees for attending these AFCEA's DC's virtual event on 5G powering smart military bases. And I'd like to invite everybody to the networking session that's going to follow. There's going to be in your chat link, there's going to be a link for joining this Zoom-based virtual meeting. So all the questions that were not answered live, you can have a discussion in this virtual networking event and enjoy that. So thank you all so much. Thanks for allowing us to be a sponsor, and look forward to seeing everyone in the virtual networking session. Thank you.